Master Data Management, MDM, data models are frameworks that define how master data is structured, stored, and related within an MDM solution. These models help organize and manage the key entities and attributes that are critical to business operations, such as customers, products, suppliers, and locations. MDM data models ensure that data is consistent, accurate, and accessible across the organization, enabling effective data management and integration. Key components of MDM data models. 1. Entities, in other words domains. Entities are the core objects or categories of master data that are critical to business operations. Common entities include customers, products, suppliers, employees, and locations. Each entity represents a key aspect of the business and typically contains several attributes, fields, that define specific details about the entity. 2. Attributes. Attributes are the specific data fields that describe the characteristics of an entity. For example, a customer entity might have attributes such as customer ID, name, address, contact information, and account status. Attributes help to define and differentiate each instance of an entity, making it possible to accurately identify and manage individual records. 3. Relationships. Relationships define how different entities are connected or related to each other within the data model. For example, a customer entity may have a relationship with an order entity, indicating that customers place orders. Understanding these relationships is crucial for accurately representing business processes and ensuring data consistency across different systems. 4. Hierarchies. Hierarchies represent the organizational structure or grouping of entities. For instance, a product hierarchy might organize products into categories, subcategories, and individual items. Hierarchies help in data aggregation, reporting, and analysis, providing a structured view of data for decision-making. 5. Metadata. Metadata is data about data. In the context of MDM, metadata includes information about the entities, attributes, and relationships in the data model, such as data types, allowed values, and validation rules. Metadata helps ensure that data is used consistently and correctly across different applications and processes. Designing MDM data models. Designing an effective MDM data model involves several key steps. 1. Identify key entities and attributes. Begin by identifying the core entities that are critical to business operations. Determine the attributes that are essential for describing each entity, considering both current and future data needs. 2. Define relationships and hierarchies. Establish the relationships between entities, such as one-to-one, one-to-many, or many-to-many relationships. Also, define hierarchies that represent the organizational structure or categorization of entities. 3. Set data quality rules. Define data quality rules, such as validation rules, data formats, and mandatory fields, to ensure that the master data remains accurate and consistent. 4. Integrate metadata. Incorporate metadata into the data model to provide context and guidance on how data should be used, ensuring that data management processes are transparent and well documented. 5. Consider scalability. Design the data model with scalability in mind, allowing for the addition of new entities, attributes, and relationships as the organization grows and evolves. 6. Align with business processes. Ensure that the data model aligns with the organization's business processes and goals, enabling the MDM solution to support decision-making and operational efficiency. Conclusion. MDM data models are the foundation of any master data management solution, providing a structured approach to organizing and managing critical business data. These models define the entities, attributes, relationships, and hierarchies that make up the master data, ensuring that it is accurate, consistent, and accessible across the organization. By carefully designing and implementing MDM data models, organizations can achieve a unified view of their data, improve data quality, and support better decision-making across their business operations. I'm on the data side. Which side are you on?